Alright guys, today we're going to look at balancing oxidation reduction reactions. Hopefully in the previous lesson you learned how to identify oxidation and reduction, and you learned how to identify or assign oxidation states. In this section I'm going to talk about how we balance them, and these can be a little tricky. These are can be quite advanced in the way they balance. It just comes down to memorizing the steps or understanding the steps, I guess. So oxidation reduction reactions can quite often become very complicated. What we do typically with balancing equations is we do it through what's called inspection. So we see that there's two carbons on one side, I put two on the other side, and we use coefficients for that. Well, oxidation reduction isn't going to be that easy because there's some other strange things that happen, and I'll try to explain it as we go. Balance, we're going to do is break these up into half reactions. This is referred to as the half reaction method because we're going to break these up into half reactions. Then what we're going to do is we're going to balance the half reactions separately, then we put them back together, and basically that's it. So we just try to focus on them in two half reactions, and hopefully kind of get the idea that the half reactions will be oxidation half and reduction half. Don't worry about this here. We're no longer doing basic solutions. AP has never really done basic solutions, so we're not going to focus on that. Everything you're going to do is an acidic solution, and that's going to be important because it's the acidic solution that makes these kind of complicated to balance. Alright, so what is a half reaction? A half reaction is going to take place, the oxidation and reduction is going to happen separately. Now, it doesn't really happen separately, but we're going to focus on them separately and then put them back together. Now, keep in mind we're going to focus on splitting the oxidation and reduction half into pieces, and then we're going to have to include electrons because the whole idea is one of them is going to lose electrons and one is going to gain. Remember, oxidation loses the electrons, reduction gains them. How do I remember that? Because I want my charge or my oxidation state to be reduced. I want the oxidation number to go down, so therefore I have to gain a negative charge for that to happen. So reduction is the gaining of electrons. Alright, let's take a look at the rules. And these seem really weird. I know the first time I did this, I had no idea what I was doing. I just kind of followed along and just kind of balanced them in. I think most of you will probably be there as well, but I'll try to get you to some understanding of it. Alright, so what I'm going to do is first separate the oxidation reduction. Then what you're going to do is you're going to, for each half reaction, you do this twice. You're going to do this for each one. You're going to balance all the elements except hydrogen and oxygen. The reason for that is because of the way hydrogen and oxygen are going to work out in the reactions. Oxygen is going to be used to balance, you're going to use water to balance oxygens, and you use hydrogen ions to balance hydrogen. And I know that right there is where everyone's like, what? What are you talking about? Just kind of go with it, okay? Just bear with me for a little bit. Okay, then what you're going to do is you're going to balance the charge with the electrons. So you got to make sure that the charges are balanced by losing or gaining electrons. Then we're going to join the two half reactions together, and the way we do that is we have to equalize the electrons that are transferred. So if the oxidation loses 2, the reduction needs to gain 2. The oxidation loses 10, then the reduction has to gain 10. Alright, and then we add the two half reactions together and we cancel out anything that's the same on both sides, and we write the net result. Boom, right? Not too bad, okay? Yeah, I'm sure you're probably very confused at this point. So, let me go ahead and clarify this by doing an example for you. I'll do number 1. Alright, number 1 is permanganate ion reacting with iron and producing iron ions and some manganese 2+ ions. Okay. Now this would most likely be potassium permanganate and iron nitrate and some nitrate over here as well for the manganese. So they kind of drop that part out. We're just focusing on the ions. First thing I need to do is assign oxidation states. Oxygen is always -2. Since I'm not going to write all the numbers at the bottom, if you need some help with that, you can kind of slow it down and practice it yourself. I'm just going to kind of do it in my head here. So for the, hold on. Let's actually go ahead and write these out. So I wanted to get rid of that equation. So I'm going to go ahead and write this down here. So -2, when I have 4 of them, so that has to be -8. Overall, I have a -1 charge. So my manganese needs to be +7. So therefore, I'm going to put a +7 for my manganese because I only have 1 of them. Alright, I figured I'd do this one more time to kind of make sure you guys all understand it because I'm sure you're a little confused. +2, +3, and +2. Okay, pretty easy because they're just ions. Alright, so what's going on? What's the change that's happening? What's undergoing reduction? That's the one I always look for first. I always look for reduction first. Well, the manganese is going from +7 down to -2. So that's going to be my reduction. My oxidation is going to be the iron. Iron is undergoing oxidation. Why? Because its charge is going up. It has to be losing electrons. this has to be gaining electrons. So for the balancing purposes, what I'm going to do is I'm going to separate these out. I'm going to write reduction here, and I'm going to write oxidation over here. I'm going to separate out these two half reactions. So I'm going to start with MnO4 2 minus 1. Okay, and I'm going to write that as Mn2 plus. That's my half reaction. Over here, iron 2 plus goes to iron 3 plus. So I have my half reactions written out. Alright, now what I'm going to do is I'm going to balance just like I did. I'm going to follow the rules that are on that previous slide that I talked about. I balance my elements. Manganese are balanced. I have to balance the oxygens. To balance oxygens, I'm going to balance them with waters, not just oxygens. I'm going to use water. So I'm going to put water here, and I need 4 waters. Water, 4 oxygens, and 8 hydrogens. Now, this next step was to balance the hydrogens. Well, to balance the hydrogens, I have 8 hydrogens now on this side. I have to put 8 hydrogens on this side. And I balance them by putting hydrogen ions in here. And I'm going to throw in here an 8. Okay? So 8 hydrogen ions per manganate. Now, is everything done? No, I've got to do the last step. I've got to balance the charge. Well, I went from a positive 7 to a positive 2. So how many electrons were lost in this process for each manganese atom that I had? Hopefully you can see this pretty easily. It's going to be 5. Now if it's reduction, am I gaining or am I losing electrons? In order for it to go from positive 7 to positive 2, I have to gain 5 electrons. Alright, so I have to gain 5 electrons for that to happen. So this is my half reaction for my permanganate. Okay? Over here, I have to get the electrons to be lost, right? Because oxidation is loss of electrons. Well, how many electrons are going to be lost if iron is going to go from 2 plus to 3 plus? It has to lose 1 electron. So I'll put 1 electron on this side. Now, both half reactions are balanced, independent of each other, and I'm going to bring them together, but the electrons are the unifying factor. So what I have to do for this reaction is I have to multiply this by 5. So this whole reaction needs to be multiplied by 5. So therefore, what I'll have is I'll have 5 Fe2 plus, iron 2 plus ions. I'll have 5 of the iron 3 plus ions, and I'll also have 5 of the electrons. Now, if this is an electron is on the reactant side and this electron is on the product side, I'm going to cancel that out. Right? We don't need to see the electrons transferring. And all I'm going to do is I'm going to take my reactants and combine them back together. I broke them apart. Now I'm going to unify them back together in one overall reaction. So I have 8 H plus hydrogen ions. I have manganese or permanganate ion plus 5 iron 2 plus. Yields manganese 2 plus, and I have 4 waters, and I also have 5 iron 3 plus. Look at that. I mean, that's a monstrous equation, right? I mean, that you've not seen things like that. Typically, we stick with 2 reactants, 2 products, like I said before. But here we can actually have 3. And as I said, these can get a little intense in their size. But anyway, here's the idea. What's happening is we are balancing this in acidic solution. So if I want this permanganate to react with the iron, it's not going to work if I don't have an acid added to this. So I have to make the solution acidic by adding hydrogen ions. By adding the hydrogen ions, then the reaction will happen. And we'll do this a little bit later in a lab where we actually will have acidified solutions for this process to occur. Anyway, so 8 hydrogen ions. Now when this reaction occurs and happens and the permanganate goes to the manganese ion, these electrons are lost. I'm sorry, the oxygens are lost. They're bumped out. Well, the oxygens, what they're going to do is they're going to bond with the hydrogen. That's why we need these to be here for the reaction to happen, for those oxygens to have a place to go, because it's not going to oxidize the metal. The metal is oxidizing. The term oxidation is used in 2 ways. I'm not going to bond oxygen to the metal. I'm going to bond the oxygens to the hydrogens. So therefore, that's why I get the water. That's why we have to balance the oxygens with water, and we balance the hydrogens with the hydrogen ions, because we need this outcome to happen. If you don't understand that part, not a big deal, but that's pretty much how you balance these reactions. I'm going to do one more if you want to stick around and watch, otherwise you can stop the video and we'll kind of talk about it in class. But if you'd like to see one more example, I'll do one more for you. Alright, let's take a look at chromium, or the dichromate reacting with a chlorine ion to make chlorine gas and chromium ions. Okay. So what I'm going to do is I'm going to assign oxidation states, and I'm going to quickly do these. I'm not going to stop and do them by steps this time. My oxygen is going to be -2, -14. Because I have -2 here, it's going to be +12, so therefore I have to have a 6+ charge on my chromium. Chlorines are going to be -1. Chlorine here is going to be a 0 charge, and of course the chromium is a 3+3 charge. Okay? Alright, I remember oxidation state's number in the front just to kind of make it so it's not a real number. Alright, so what's going through reduction? Remember, I like to find reduction first. To start with reduction, I'm probably going to start with the big number here, so 6+ goes down to 3+. So there's my reduction, and therefore the oxidation has to be chlorine going from -1 to 0. So that would be my oxidation. It's going up in charge. Feels like it's going down, but it's -1 going to 0. It's actually increasing. So that would be my oxidation. Alright, so write them both out in two half reactions. My redox I'm going to put over here. Oxidation I'm going to put over here. Alright, so you got chromium dichromate, 2-, and that's going to go to chromium 3+, and I have chlorine minus, and I have chlorine. Alright, so come over here, balance my chromiums. I need 2 chromiums here because I have to balance the chromium because I have 2 of them here, so I got to put a 2 in front. Balance my oxygen, so therefore I need a 7 for the waters because I balanced the oxygens with water. Hydrogens are now balanced with hydrogen ions on the other side, so I need 14 hydrogen ions on this side. Alright, so hydrogens are balanced, 14, 14, 7 oxygens, 7 oxygens, chromiums are balanced, chromium are balanced. Now because I'm putting charges in here, I have to balance the charges because I've been changing them by putting 2's in front and 14 hydrogen ions. So to do this, I'm going to have to throw in here some electrons. Alright, so the electrons that I'm going to throw in here depend on the chromium. Now this one's a little confusing, so be careful. Alright, so what I'm going to do here is I'm looking at chromium is a 6+, goes down to a 3+. That is per chromium atom, right? So each chromium atom is going to gain, it's going to gain 3 electrons because we're going through reduction. But I have 2 of them, so they have to gain 6 electrons, right? Because each one is going to gain 3. So try to look at that, see if you can figure out what I'm talking about because of the number there. If not, we'll talk about it in class. For the chlorine, I have to balance the chlorines because I have 2 chlorine atoms, and now how many electrons? Because it's a loss of electrons. The electrons always go on this side. It's 2. Alright, so now to bring the 2 equations back together, I have to multiply this one to make the equation. You might have to multiply both of them, so be careful with that. Alright, so 3 to make the electrons equal to 6. So I got 6 chlorine ions forming 3 chlorine molecules and losing 6 electrons. The electrons are going to cancel, and therefore I can now bring these 2 equations together. Okay, bring them together and just sum up everything. So 14 hydrogen ions plus dichromate, plus 6 chloride ions produces 2 chromium 3+ ions and 7 waters, and finally 3 chlorine molecules. And there is my balanced equation. Okay? A couple things you can do to check this, I'll show you some other ways later, is that if you look at the charges on this side, I have a +6, I should get +6 on this side, so I've got +14, -6, -2, so we should end up with it. So -6 and -2 is -8, 14 minus 8 is going to give you +6, +6. So the charges should match on both sides. Your elements should match, 6 chlorine, 6 chlorine, 14 hydrogen, 14 hydrogen. So just like any other balanced equation, everything should match on both sides. Alright guys, I'll answer all your questions in class, and I'll see you later.